So what is a pointer? A pointer is essentially a variable that points to other variables, and it can. The reason that we use pointers, so why I use pointers, is that they allow us to string variables together to make data structures, such as linked list. But they also allow us to indirectly access variables, which is a very convenient thing to do. So what is the declaration of a pointer? I'm going to put very quickly, make it a function here. So the declaration of a pointer would look like this. So let's say we have an variable called x. Let's say it's equal to 7. It will look like this. Let's say, let's put ptr is equal to, we'll just initialize it to nothing initially, and then we'll make it point to the variable x, right? This is, generally speaking, how it will look. You don't have to initialize pointers to anything, and you can just assign them later, right? So what is a pointer initialized to? It is initialized to just a random memory location, so you don't really want to be messing with pointers that are pointing to just random things, because that can cause undefined behavior, and we really don't want that, right? So what is null pointer? So for example, here I could say make this equal to null pointer. It's essentially saying we're pointing to nothing, which is really important because sometimes you do want your pointer to point to nothing, not to just a random location, but literally nothing, so that you can compare it to other things. You might see syntax that looks like this online or in textbooks. This is bad because null isn't actually nothing, it's 0. So this is the same thing as saying pointer is equal to 0, which can cause a lot of problems, and it can cause a lot of bugs, and famously causes tons of bugs and a lot of old code. How do you dereference a pointer? Well, you can do it by using the asterisk. Let's say we have ptr, and let's say we want to change this x variable, right? We can, let's say, make this equal to 10. I'm going to just comment these just in case you wanted to try to run this, but so this is going to change this x variable to 10, which is pretty useful to do, right? What is the membership and operator and indirect membership operator? You've probably already seen these before. The membership operator is essentially just a dot. So let's say we have like a car object, right? What we can do is just do object, let's say dot function to access one of the functions that is in this car class, right? But if we are using a pointer to that object, or let's say object 2, the way we access it is not through a dot, but it's actually through an arrow. And this is doing a couple things. It's actually dereferencing it and then accessing it. This is just part of the syntax that's built in. So what is a reference? A reference is another part of the language that is similar to pointers, but it's also slightly different. Let's just make a new one. Okay. So essentially, references allow you to, instead of pointing to other objects, it allows you to have an object that is stored in the same memory location as that object. So essentially what a pointer does is it's a variable that points to another variable. What a reference is let's say we have a variable here called x that lives in here, is it creates a variable that exists in the same place as the original variable. So if we change x or we change y, they will both change. So essentially they're the same variable and they're linked to each other, right? So what does the declaration of a reference looks like? It will look like this. It's like int reference y is equal to x. Now what's important to note is that I can't actually do, let's say, something like this. This is not allowed in your program won't compile, because as a rule, references must be initialized to something, right? And this is starting to get to what are the advantages versus disadvantages of pointers versus references. Pointers don't have to be initialized to something, and they're much more dynamic, and you can move them around and change what they're pointing to very quickly. As you can see, it's just a quality. But references are a little bit more, they're definitely safer, but they are slower, and in a lot of situations you're just going to want to use pointers if you want to do something like very quickly. But if you want to do something very safely and make sure everything works correctly, you want to use references because they're just better. So what is passing by reference versus passing by value? So here we're going to very quickly write some functions. One of them is going to be called passing by value, which is something that you've probably already, it's basically the only thing you've ever done, which is, let's say, a function that looks like that, and then we're going to have void passing by reference, right? And let's say we have int ampersand d. So essentially what passing by value does is, let's say we call this function, right? We call passing by value, and we pass in x, right? So let's say in here we do c plus equals 17, right? So we are adding c equals c plus 17, essentially. What's important to note is that if we were to do a cout after this, cout x, This is still 10, which is what we changed it to here. But what passing by reference does is we pass in the original memory location of the variable, which allows us to actually change what the variable is in a different function, right? So like, let's say here we do pass by reference, right? And we pass in x. If we were to run the exact same code, c plus equals 17, what we would print out if we do c out x is not 10, it's actually, what is it, 27, right? Because we're adding just 20, we're adding 17 to 10, right? Which means that like this is actually affecting the original variable, which is really important. So the last thing is, what is dynamic memory? What is stack and heap? Stack and heap are two different places in which memory is stored. Generally speaking, stack. The trick for C++ is to heap variables, use new, stack variables don't, right? So, whoopsie, don't. So let's say we make a variable, right? Int x is equal to 7, or int, let's call it u is equal to 10, right? This is in the stack. But if we make, let's say, an array, right? Int pointer array is equal to new int, let's say, size 10. This lives in the heap because we're using the new keyword. What the new keyword is, it allows us to allocate memory in a different part of our computer, usually some sort of RAM, right? Which is much bigger than just the memory that's on the stack, and it allows us to store things for longer. So what is dynamic memory? Dynamic memory is essentially any kind of memory that we use the new keyword for, because it allows us to have much more space to work with. And if you want to use like arrays in C++, you will have to essentially use new, unless you want to do something like this, which as you'll learn becomes very clunky. So as you can see, an array is a pointer, which means that everything that you'll use dealing with arrays has to deal with pointers to some extent. So what is the function of new and delete? New creates memory, while delete deletes it, right? So if we allocate this memory, then before the program finishes, like before this break, we get to this brace, we should delete it. So ideally we want to do, call this, we want to delete array, right? We want to run this line before our program ends. But essentially this is all you will need for this quiz. If you have any questions, just reach out to me.